If we look at cosmic shear, then, and weak lensing, then this is bringing a connection back to that. Clearly we've got large data sets already present and are coming from existing telescopes, never mind what might happen in the future. Most of the current approaches are basically statistical. You do these large statistical analysis somewhat like mimicking what you do with a microwave background. That's a good model to follow. It's perfectly good, and it's already led to interesting results, and I'm sure it will lead to many, many more. But as an alternative, you know, the hope is to vindicate, I should say, I meant to write it vindicate or refute flat lambda CDM, depending on your personal predilection. But, you know, we just be objective. Personally, for my part, I'd love to see flat lambda CDM disappear and, you know, be replaced by something more interesting dynamics. But my expectation is that this will just become more accurately vindicated. The alternative approach is not a statistical one, but it's an individualistic one, and it uses individual lines of sight, somewhat aping what we've just described for the strong lensing. If you can devise a sufficiently good prescription using the photometry and the photo-Z's and so on to get the halos in the background, or some equivalent prescription like that that takes you from light to a mass with a good predictor, then you can predict the convergence and shear as it evolves along individual rays, all the different rays on the sky in your field, and the image, by extension, the image shape, so you've got the real images, and you then get the shapes of the galaxies that created them. This can be done extremely efficiently using this matrix formalism, where there's a way of sort of rastering this backwards and forwards. You don't have to do each ray one at a time. You go backwards and forwards, and you work your way out back in time. And so it's a very efficient way of doing this. I'm personally not frightened by the large number of galaxies. And then using this approach, on the one hand, you're sort of seeking consistency in the cosmology. That, of course, would be the holy grail in this sort of flat lambda CDM. But the other thing is, you know, maybe through one means, maybe the statistical method and so on, we become sufficiently confident that the cosmology is correct. Then this becomes a real tool for studying galaxy formation, merging, the intrinsic effects we heard about yesterday, understanding what the shapes of galaxies are as they are apparently merging as we look back in time and see that. I think you could actually use this as a way of understanding cosmogony in a very detailed way, because the amount of data you're going to have is going to be truly enormous. So let me just wrap up with a very, very sort of quick summary. Point I was trying to make is that, you know, when doing this multi-plane weak lensing, you have to allow for the underdense regions as well as the overdense sheets, so that we have negative curvature. There's a matrix method which can be used very efficiently and can in principle combine with observations. The direct effects on the time delay are small, the indirect effects are for the Hubble constant, and it only affects the modelling, and this is sort of the way you have to do the modelling in the lens plane, not on the sky, which has been the way mostly people have done it so far. So those are the main messages I have here. Thank you very much indeed.